अच्छा दिस वन उधर से पहले तो एल्कीन्स ठीक है वी डिड एल्कीन्स एल्कीन्स का मैंने कहा था कि द पाई चार्ज डेंसिटी इज वेरी स्ट्रांग ठीक है द इलेक्ट्रॉन्स आर वेरी कॉन्सेंट्रेटेड सो वेरी स्ट्रांग अट्रैक्शन फॉर इलेक्ट्रोफाइल्स तो दे हैड इलेक्ट्रोफिलिक एडिशन रिएक्शंस और वो सारे इलेक्ट्रोफिलिक एडिशन रिएक्शंस थे देयर वाज ब्रोमिनेशन देयर वाज हाइड्रेशन हाइड्रोजनेशन HCl के साथ ठीक है वो सारे रिएक्शंस थे और we did the Markovnikov's rule कि I explained to you कि carbocations that have low charge density are more stable carbocations that have high charge density are going to be less stable ठीक है so carbocations with more electron donating alkyl chains are more stable as they have lower charge density तो उसमें there was a major and minor product ठीक है we did that as well तो electrophilic addition high electron density the bromine molecule will get polarized and one of the bromines is going to get knocked out. One the positive bromine is going to get attracted, okay, uh, to the double bond. So one of the bromines gets attracted, the other one gets repelled. It forms a carbocation, two different carbocations, okay. One of them is stable, the other one is unstable, and ends up in next step में वो the Br-1 comes in. ठीक है, that was electrophilic addition. अब उस पे आ जाते हैं alkenes, sorry benzene. So we need to do इसके नीचे start करते हैं. What we need to do is we need to do electrophilic substitution of benzene now. Okay, which is going to be very similar. Because it also has a pi electron charge density. So this is called electrophilic substitution of benzene. ऐसे पहला टॉपिक ही है ठीक है that's electrophilic substitution of benzene. This is like very important. You get I mean that this is like one of the major topics. So ठीक है electrophilic substitution of benzene. One second, let me highlight it. So that's like one of your major topics. Now what happens is I'm going to come back and draw the Malosiko. I'm just going to copy paste the benzene. Okay, that's my benzene. And let me take the pi electron cloud. Okay, that's on top and below it. So now it has two. I mean, the first one, it's got a reaction which is known as bromination or chlorination. That's the number one electrophilic substitution. Okay, that's bromination, or it could be chlorination as well. Now, there's going to be one major difference between bromination of alkenes and benzene. And let me just get rid of all the ये बीच में जो ठीक है, I'll draw that again one second. Here there's one bond. One second. Okay, that's my pi electron cloud. ठीक है. तो ये नजर आ रहा है. Is this clear? मतलब स्क्रीन पे नजर आ रहा है. Is this clear?
Yes, sir.
अच्छा, now what's going to happen? कि bromination would happen. ठीक है, exactly the same way as ये alkenes. So bromine molecule is going to come close to it's going to get attracted to this benzene. एक सेकंड रुकना ये हैंग कर रहा है ठीक है अब सही है अच्छा it's going to get attracted to this benzene it's got electrons it's going to get polarized the same way ठीक है the charge density over here the electron charge density over here is going to repel the bromine one of the bromine is going to become positively charged and the other one is going to become will have a partial negative charge but there's going to be one thing that's going to be different and that one thing that's different is the polarization is not going to be very large so there's going to be weak polarization of bromine Why? Because the pi electron density in benzene is not, it doesn't have a high charge density. Density of benzene is smaller compared to alkenes. And hence there's less polarization. The electrons over here are not going to be repelled very strongly. क्योंकि remember वो हमने पहले पढ़ा था कि why is there less polarization? Because why is it less polarization? Because the pi the p orbital is overlapping on the left, it's also overlapping on the right side, so the electrons are more distributed. ठीक है? So the electrons are partially over, there's a partial overlap on the left and partial overlap on the right side. The electron density is significantly lesser compared to alkenes. So is this clear? Okay, the polarization is very weak. Is this part clear?
Yes, sir.
So the positive bromine is going to get attracted. It's going to get attracted, like it's the attraction is going to be very weak, and there's not going to be any reaction. Because initially there's not going to be any reaction. So which is why the bromination reaction is not going to be as simple as the one that happened with alkenes. In alkenes, you had really strong polarization. Okay? The positive bromine was very strongly attracted. Now it's not going to be that strongly attracted. So in this case, to increase the polarization, what you need is you need a catalyst. Okay? So there's a catalyst that's added, and okay, you got a couple of options for a catalyst, but it's for example over here it's FeBr3 that's added. So so a catalyst is needed to increase bromine polarization. So what the catalyst? Remember, what do transition metals do? They have a strong attraction for electrons. Okay, that is what we learned about transition metals, that they have got more protons, so they're slightly unreactive. They don't like to lose electrons. They actually have a weak tendency to attract electrons as well. So what the iron over there would do is that the benzene is trying to push the electrons from one side. Okay, this is what the benzene is it's trying to repel the electrons in bromine. Fe, on the other hand, will try to attract those electrons. Okay, so it's going to try and attract those electrons. So in this way, the polarization would become bigger. It's going to become larger because one side is pushing the electrons, the other side is attracting the electron, and that's how the pol the slight positive and slight negative charges on bromine will build up further, and and the polarization would then become much higher. Okay, is this clear? So without the catalyst, the bromine molecule on its own is not going to get polarized. You clear? Is this part clear?
Yes, sir.
Acha, and now the bromine is going to get attracted to the benzene. So so the bromine molecule will split up. Okay, the negative part will get attracted to the iron. The electrons are going to get knocked out, not because benzene is repelling them. It's more due to iron attracting those electrons. So the next part is this is the first part. So the next part is okay, you take this and okay, so I'm going to draw step number two. So step number two is that the bond has been broken. Okay, I'm going to rub all of this. The negative, so one of the bromine becomes -1, the other bromine becomes +1. The -1 negative bromine will get attracted to, it's going to take away the electrons, and the electrons are going to datively bond with Fe over here. And the other bromine will become positively charged. And that positive bromine will get attracted to the electrons in the pi electron cloud over here. There are 6 electrons, but it's going to get attracted to just one of them. So it's going to get attracted to one of the p orbitals, which was overlapping and forming a pi bond. That one electron would then start bonding with, so the overlapping would end on this side because that one p orbital would end up bonding with this particular bromine. Its electrons are going to get pulled by this positive bromine. It's going to come in, and the carbon would start sharing electrons with this bromine, and the bromine positive charge will go away. Okay, is this clear? So the pi electron cloud of benzene is going to be it's going to be partial. One of the p orbital is now missing because that p orbital is now bonded to bromine. Is this clear?
Yes, sir.
ठीक है और ये भी होता है कि the rest of the benzene gets a positive charge. So there's going to be a positive charge on the rest of the benzene because one of the electrons in the pi electron cloud is missing. It's been taken up by bromine. Is that clear? और फिर आपके पास next step है which is that the benzene pi electron cloud is very unstable at the moment. ठीक है, at this point it's very unstable. So this is an unstable benzene ring, and it needs its electrons back. So who likes to lose electrons? Hydrogen over here has a very high tendency to lose electrons. So what happens is, so instead of like the previous reaction, instead of in this reaction, what happens is that so remember this, okay, and let me explain to you one thing. Just like a carbocation, this is also a carbocation, but the problem over here is that the positive charge is distributed over a lot of carbon atoms. So मुझे बताओ, is the positive charge density strong or weak? Okay, in this
Sir,
case,
strong.
नहीं लेकिन वो देखो ना positive charge is now distributed, it's delocalized, it's over the entire benzene ring. जैसा पहले था ना, like in alkenes, what happened in alkenes? That the positive charge was on one carbon atom, that's it. Okay, which is why the positive charge density was more concentrated, which is why it was strongly attracting Br minus one. Now over here, the problem is the benzene pi electron cloud was acting as one thing, right? And bromine took an electron and bonded with one of the carbon atoms. So the positive charge is spread over all the carbon atoms. Is that clear?
ठीक है सर.
So the positive charge density is very weak. Okay, so which is why it will not attract the Br minus one. Well, that's too far away. There's going to be very weak attraction. This positive charge is not going to be that strong. So what it does is that it wants to stabilize because there's one electron missing. So it pulls an electron from the hydrogen over here. That electron is going to come back, and where would the hydrogen go? It's going to bond with the bromine, which bromine minus one. These two will end up forming HBr. The electrons that are over here, they'll form the p orbital again. So in the next step, what happens is okay, I'm going to draw a simplified diagram after this. So the next step that happens is that this Br minus one and this HBr, they bond together and they're going to form HBr in the middle. Okay, so they end up forming HBr. Uh, what happens to the electrons that the H left? There's going to be a Br over here. The electrons that the H gave away, those electrons will form the pi bond once more. So you'll have a p orbital once more. Okay, so the p orbital would reappear, and the overlapping would begin again, and the benzene ring it's going to become complete again. Okay, they'll start overlapping above n. The positive charge in the middle, that's going to disappear because we've got the electrons back. And HBr gets formed, and those are your products. So that's the simple two-step reaction mechanism for this. TK, you'll not be asked to draw all of this, but you need to develop an understanding of how because electrophilic substitution is very important. We're going to study a lot of cases of electrophilic substitution. So, ठीक है, there are many versions of electrophilic substitution. So you need to be ready for this. You need to be ready for the details as well. So remember the difference between alkenes and this. The first difference was that the polarization was not that strong. So which is why you needed a catalyst. Catalyst was required. And the catalyst would increase the polarization. And then the positive bromine is going to get attracted to one of the p orbitals and it will bond with it. And the negative bromine is going to go to the other side and will get attracted to the Fe. And then what happens is that the positive charge on the benzene is not that strong, so it's not going to attract the Br minus one like in alkenes. So what it does is that it stabilizes itself by pulling electrons out of the H, the nearby electrons. And the H is always willing to lose electrons. So H is not very electronegative, so it always loses electrons. So the H lost its electrons, the p orbital gets back into position because the H lost those electrons and they come back, and the pi electron cloud gets reformed. The benzene becomes very stable again. You can remember benzene is a very stable structure. So it's no longer, so you've got a stable benzene ring back again, HBr gets formed, and with it, you've got FeBr3 as a catalyst that reappears. So is this clear, the whole mechanism? Is this clear?
Yes, sir.
ठीक है. अच्छा, अब ये कि the next thing what I'm going to do is I'm not going to I'm going to draw the simplified version. You're not obviously this drawing. I mean, especially this drawing, that's like kind of really difficult to draw. So I'm going to draw the simplified version, the one that you're going to draw in the paper, which is so this is electrophilic substitution mechanism. So electrophilic substitution mechanism, the simplified version of the drawings that we did. So it's simple. You start off with a benzene. Do we have a benzene? No. Give me 1 second. Yep. So we start off with a benzene, and so I guess that's a benzene. It's been a bar, but you have to draw up a lot of benzenes. Okay, that I guess that's enough. So we're drawing the mechanism. So bromine, electrons. The benzene electrons are going to be attracted to this positive bromine. This is your negative bromine. The bromine is getting polarized, and the electrons are getting repelled. Well, let me. And then there's an FeBr3 catalyst. Okay, that attracts electrons from the other side. Okay, that's the first step. Step number one. So step number two is the same benzene. It now bonds with the positive bromine over here. So there's an H that's already bonded to it. Okay, this one already has an H. Just a second. I said it already has an H, and it's got a Br bonded to it now. Plus, it's going to be a carbocation. So the benzene electron cloud will be partial. The overlapping would not be happening on this side. So that's going to be your benzene turning into an iode. And the FeBr3 is now FeBr4 with Br datively bonding to Fe. And that's -1. In the next step, what happens is that the curly arrows again, TK, the H electrons over here, are going to complete, they're going to come back and they're going to complete the benzene ring. And the Br electrons on the other side, they're going to come back and they will bond with the H. So that's your second step. And finally, you draw the products. So the products now are K. So what are the products? The positive charge is gone. Okay, let me just redraw everything. So the final product is okay, you've got Br now attached. Okay, so we've got a Br attached. HBr is formed, and we've got FeBr3 back again. So is this clear?
Yes.
So, and this is everything has to be exactly the same. It's going to be asked. You'll be asked to draw this very very frequently. Okay, that's the electrophilic substitution mechanism. Not just for this, there'll be other but the mechanism would pretty much be exactly the same. Okay, ये clear है? So, and I'm going to write the simple reaction as well. So the simple reaction is like without the mechanism. So the simple reaction is okay, you've got so you just have benzene and a bromine gets added to it. And HBr is the byproduct. So you reacted with bromine. There are actually two reactions. There's chlorination and there's bromination. So the simple reaction is you add bromine and TK without the mechanism. And TK you add an FeBr3. Remember there are two options for a catalyst. There's FeBr3 or AlBr3 as well. You could use that as a catalyst as well. And so what you're going to get is substitution. One of the H's which you can't see in the skeletal formula, that's going to be substituted with bromine. And where did the H go? That will form HBr. ठीक है clear है?
Yes, sir.
और इसके actually दो reactions हैं. There's chlorination as well. So chlorination is exactly the same. So chlorination is exactly the same except कि instead of Br2 it's going to be Cl. So you're going to have Cl2 and there's going to be Cl over here and there's going to be HCl that's going to be formed. And the catalyst would also be not AlBr3 or FeBr3, it's actually going to be AlCl3 or FeCl3. ठीक है? So catalyst is going to be needed in both cases. So remember, bromination without a catalyst only happens with alkenes. Uh, for benzene, you need a catalyst. The main difference तो ये है कि and it's going to be a slow reaction. This one is going to be a lot slower reaction. ठीक है? So that's the first one. And remember, there's going to be a lot of variations that we're going to study down the line. तो ये वाला clear is this clear to everyone?
Yes, sir.
बाकी clear हुए. Ikshita, is this clear? Amna, is this clear? Okay. Now the next one is कि again that's electrophilic substitution. अभी बहुत चलेगा. There's going to be a lot of electrophilic substitution. This you can say this was one. Did I write one? Yeah, that was one. Bromination or chlorination. Now number two. ठीक है, number two is that's known as nitration. ठीक है, that's number two. So what happens in nitration is that पहले तो simple reaction. ठीक है, simple reaction is कि I've got a benzene and it's got ठीक है, so I've got this benzene. Center कर लें उसी के. So nitration is that I'm going to react it with I'm going to react it with I'm going to tell the conditions first, and then we're going to come to mechanism. So you've got concentrated nitric acid and concentrated sulfuric acid, and the temperature has to be around 55. And what happens is it gets nitrated. The benzene, again, there is a substitution. I said, remember, ये benzene जो है ना, it has these H's. There's single H's over here. ठीक है, there's six H's that are bonded to it, which they're never shown in skeletal formula. So one of the H's is going to be substituted by NO2. So that is nitration. That's it. ठीक है, so remember the conditions. Remember and this is electrophilic substitution as well. So the next thing we're going to do is we're going to talk about the mechanism for this, which is kind of going to be exactly the same. I said, but the reaction has two steps. One of them is step number one. In step number one, the NO2 plus electrophile gets produced. Yeah, I'm gonna go back. TK, the bromine was I said it well, it's kind of understood. This is your electrophile basically. TK, मैं उसको label कर लेता हूँ. That Br2 is your. I mean the name may obvious था. That was your electrophile. अच्छा, over here it's NO2 plus one. That's my electrophile. As the first one, NO2 plus electrophile is produced. How is it produced? Okay, there's a reaction first. The H2SO4 reacts with the nitric acid and it ends up producing what? It ends up producing three things. It produces NO2 plus one, electrophile, it produces two HSO4 minus ones, and it produces a hydronium ion as well, which is H3O plus one. Okay, you've got to remember this equation. Okay, that's going to be considered part of the mechanism. They're going to ask you, remember this. Yeah, how does your electrophile gets produced? Okay, that's why you're adding concentrated nitric acid and concentrated sulfuric acid. You're mixing them together just to get this electrophile. Okay, just make sure that this equation is balanced. There are five H's over here, and that's three and okay. The oxygens are they balanced? That's three and that's eight. कितने हो गए 11? Two and that's eight. That's 10 plus one. ठीक है, everything is balanced. अच्छा, अब इस वाले में ना what's going to happen is the next step. Step number two is the mechanism. So step number two is once that happens, then you have the I'm just going to write electrophilic substitution mechanism. ठीक है, that's उसको short कर दिया. ठीक है. Then you're going to have your mechanism, and the mechanism is the same. Okay, what's the mechanism? Okay, you have this coming in. You have a benzene. The benzene has an electron cloud. उसी तरह बिल्कुल exactly the way bromine happened. The NO2 plus one is going to be strongly attracted to this benzene. ठीक है. And once, as I remember over here, you needed a catalyst for polarization. You wanted, one second. Yeah, this one. As I remember, sulfuric acid is again acting as a catalyst to get the NO2 plus one. But you somehow have to help this reaction out because the substitution does not happen on its own. It's not going to be a fast reaction. So NO2 plus one comes in and it then reacts with it. ठीक है, तो अगले स्टेप में NO2 plus one goes and it bonds with the benzene. ठीक है, so it bonds with one of the carbons in the benzene, and there's going to be an H over there as well. And that benzene, उसका जो electron cloud है, that's going to become partial. It's going to become positively charged. ठीक है. और next step है, how does the benzene stabilize itself? It steals the electrons from the H. So H के जो electrons हैं, it's going to steal those electrons. Where does the H go? There was an HSO4 minus one that was formed. So the H goes and joins with it, and the H leaves its electrons, and the benzene electron cloud becomes complete. So next step है कि the benzene electron cloud has become complete. There was already an NO2 attached to it. Or where did the H go? It went and formed sulfuric acid. ठीक है, again it's a two-step reaction mechanism. ठीक है, which is kind of the same. Exactly वही है कि the positive bromine came in, took away electrons from the pi-electron cloud, bonded to the carbon atom. In the next step, the H left its electrons, so the pi-electron cloud over here became complete. ठीक है, which is exactly the same happening over here. The NO2 plus one came in, took away electrons from this carbon atom, bonded with it. The carbon was already bonded to an H, and the benzene electron cloud became partial. And the H then lost its electrons to it and went and joined with HSO4 minus one to form sulfuric acid back again. ठीक है, तो नाइट्रेशन, इज दिस क्लियर? नाइट्रेशन, व्हाट इज नाइट्रेशन? ये क्लियर सबको?
Yes.
Yes, sir.
तो दैट्स नाइट्रेशन. ठीक है. एंड ये मैं इसको हाईलाइट करूँ. रिमेंबर टू ड्रॉ दिस एग्जैक्टली द वे आई हैव ड्रॉन इट. ठीक है, एग्जैक्टली लाइक दिस. एंड दिस इज वेरी इंपॉर्टेंट. दे गोना आस्क यू अ लॉट ऑफ टाइम्स. अच्छा, so that's just electrophilic substitution of benzene, two reactions, nitration and bromination or chlorination. अब इससे आगे ये कि there's a thing called again we're still talking about electrophilic substitution. So there are other benzene compounds. ठीक है, remember we're still going to talk about this, and we're going to talk about variations in electrophilic substitution. So there are compounds which are not exactly benzene but benzene derivative compounds. So basically they have benzene with something attached to it. Okay, so benzene is like a perfect benzene. Perfect benzene don't really exist in nature. There's always something attached to it. So so when you have benzene compounds, I mean you should at least have some basic idea of naming them as well. So the first one, benzene derivative compounds. They're known as arenes. Arenes are compounds which have carbon chains attached to them. So it's like a benzene with one side, there's one H missing. ठीक है, you've got H's over here, but on this side the H has been substituted by an ethyl group. This is the name of this molecule is going to be known as ethyl benzene. ठीक है, that's just ethyl benzene. Similarly, you can have methyl benzene or propyl benzene. So these are known as arenes. That's number one. I said then and it could have multiple chains as well. You can have multiple chains. So for example, I've got a molecule which is an ethyl benzene. It is also a methyl benzene as well. Just a second. Okay, let's make it propyl benzene. So I've got a molecule which is CH2 CH3, and then it's got a methyl group attached over here. So it's got two branches basically. It's a benzene, but it's got two branches now. It's got branches are always written alphabetically, so it's got propyl benzene and it's got methyl benzene. So there are two branches, methyl and propyl. That's propyl, and this one is methyl. Okay. I say you have to number them as well. So you number from the side the closer side that gives smaller numbers. So this is going to be one, this is going to be two, and this is going to be three. So there's one propyl benzene and three methyl benzene. ठीक है, it doesn't really matter कि circle में ना which side you're because it's a circle. So you count from whichever side you find reasonable. They're not going to look into. Achha, the thing with naming benzene is that the systematic nomenclature it doesn't really apply to benzene. ठीक है, most benzene derivative compounds they have their own names. Uh, so there is a certain systematic naming, but it kind of fails very, very quickly. So you don't really have a lot of systematic naming in benzene, ठीक है? Because the molecules are just too complicated. So they just give them random names. अच्छा, ये पहला arenes clear है? That's arene. Is that clear?
Yes, sir.
Second one, second important, ठीक है? That's the second one that's going to be known as phenols. ये बस एक example कर लेते हैं and then we'll end the class. ठीक है? Phenols, ठीक है? What are phenols? Phenols होते हैं कि they have a benzene again. It's like an alcohol, but remember, phenol is a remember, they're all totally different functional groups. So even though it's just an alcohol, एक सेकंड benzene को जरा अच्छा phenol simply मैं बता देता हूँ कि it's a benzene that has an OH group, but also remember it's not an alcohol. ठीक है, don't consider it an alcohol. ठीक है, तो बस ठीक है, ये इस पे फिर खत्म करते हैं. अभी रिमेंबर वी आर स्टिल डूइंग इलेक्ट्रोफिलिक सब्स्टिट्यूशन. ठीक है, पहले we'll do these compounds then we'll discuss electrophilic substitution for each one of them. चलिए ठीक है एवरीवन.
Okay, sir. Allah Hafiz.
ओके, टेक केयर. हाफिज.